All right, topic for part B. We are still working on the geometry scale, the GPE B4. We're working on several 2.0 scales here. Basically, all of these kind of revolve around the same thing, parallel and perpendicular slopes. So first, let's talk about what parallel lines are. Parallel lines are lines that exist on the same plane but never intersect. So they're never ever going to touch. Perpendicular lines are lines that intersect at a right angle, or you could just say 90 degrees. And just a refresher, if you look at this picture, if you ever see that box, that means 90 degrees. Make yourself a note if you need to. All right, so let's talk about the slope criteria for parallel and perpendicular lines. Think about something. Slope is rise over run. Slope is like a rate of change. So if two lines are never going to intersect, they should be increasing or decreasing at the same rate, or they should have the same slope or the same steepness. So parallel lines have the same slope. I like the word equal here better, sorry. It says slopes have equal slopes. Or you could just put the same, it really doesn't matter. But let's write an explanation for this. So to kind of put this into words, what I just said, let's say in order for two lines to never intersect, they must be increasing or decreasing at the same rate. Slope is rate of change, therefore parallel lines must have the same slope. Pause, write that down if you need to. Okay, let's talk about perpendicular lines. So perpendicular lines are the ones that are going like this. Boop, boop. Okay. Ooh, there's a typo here. I keep finding typos in my notes. Perpendicular lines, which is what we're talking about now, have what we're going to call opposite reciprocal slopes. And we're going to write a little explanation for this as well. So let's talk about what opposite reciprocal means. You might also see negative reciprocal. So the opposite or the negative part basically means one slope has to be positive and one slope has to be negative, unless you have horizontal or vertical lines, okay? So the signs have to change. And look at this picture I drew over here. We talked about how if the line is going downhill, it has a negative slope. If it's going uphill, it has a positive slope. In order for two lines to intersect like this, one of them has to be going uphill, one has to be going downhill, unless it's horizontal and vertical, okay? So that's what the opposite or negative part means. Reciprocal, we talked about this word in the very first topic. Reciprocal is like if you flip a fraction. So A over B has a reciprocal of B over A. So the slopes have to be opposite signs and reciprocals of each other. So let's kind of put an explanation why. Let's put in order for two lines to meet at 90 degrees. Nope, I already put the degree symbol. Meet at 90 degrees. These slopes have to be opposite signs so that one is going, and I'm going to put this in our own terms, one is going uphill and the other is going downhill. And the rise and run have to be flipped. So this is a little bit of an explanation in our own words for perpendicular lines. In order for two lines to meet at 90 degrees, the slopes have to be opposite signs. So one's going uphill, one's going downhill, positive, negative, and the rise and run have to be flipped. So we can kind of write a little example. But I'm just going to use something that works for everything. If I have A over B, the opposite reciprocal would be negative B over A. Okay. First set of examples, we're going to write the parallel and perpendicular slopes to the following line. All we're focusing on is the slopes. So something we need to remember, if we're in the form y equals mx plus b, this is your slope right here, m. We've been looking at this equation a lot lately. So all it wants to know is what slope would be parallel to this line, what slope would be perpendicular to this line. So number one is already in y equals mx plus b form. So in this case, our slope is 4. So if I had a line parallel to this line, the slope would also be 4. Parallel lines have the same slope. Both lines would have to be going up 4 over 1, up 4 over 1, up 4 over 1. If I wanted a slope perpendicular to this line, we have to think, what's the opposite reciprocal of 4? Well, opposite means opposite sign. So since this slope is positive, we would want our other slope to be negative. And the reciprocal of 4, remember 4 is kind of like 4 over 1. So if you flip it, it's 1 over 4. So 4 and negative 1 over 4 would be opposite reciprocals. They would meet at 90 degrees. One of them would be going up 4 over 1. The other one would be going down 1 over 4. All right, number 2, we have 2x minus 3y equals 7. This is actually in that standard form. It's a little bit harder to tell the slope from standard form, so we want to take number 2 and we want to put it into slope-intercept form. This is from the previous video if you need to go back and watch it. But basically what you do is you just isolate y. You get y by itself. So if I want to get y by itself, that means if it's not a y, it needs to go over to the right side. So I have negative 3y equals negative 2x plus 7. And then I'm going to divide everything by negative 3. So y equals a negative over a negative always equals a positive. So I have 2/3 x plus, and I'm just going to leave this as 7/3. So remember, we're just stating the slope. What slope would be parallel to this line and what slope would be perpendicular to this line? So my slope here is 2/3. So if I wanted it to be parallel, I would keep the slope the same. If I wanted it to be perpendicular, I would do the opposite reciprocal. So the opposite reciprocal of 2 over 3, I would want it to be negative, and then you flip it, 3 over 2. Okay? I want you to try the next two. You have to get y by itself first so you know what the slope is. Then you can tell me the parallel and perpendicular slopes. So pause it, unpause it when you're ready. Solve for y first. Okay, if it's not a y, it needs to be moved. Y needs to be completely on its own on the left side. So 3y equals negative 6x plus 3. Divide by 3, divide by 3, divide by 3. Negative 2x plus 1. Okay, so my slope here is negative 2. So for a parallel line, my slope would be negative 2. For a perpendicular line, change the sign. So instead of a negative, I would have a positive, and then the reciprocal of 2 is 1/2. Okay. And last one. Get y by itself. So I'm going to take the negative 5x and move it over here. So negative y equals 5x plus 10. Okay, and if there's a negative out in front and you want to get rid of that, basically what you do is you divide by negative 1. Or you could just think of it as, hey, I got to flip the sign of everything. If you flip the sign of everything, then you're good. Okay. So this one, my slope is negative 5. So parallel would be the same, negative 5. Got a slope of negative 5. For a perpendicular line, my slope would be positive 1/5. Okay, graph a line parallel to the given line. Then graph a line perpendicular to the given line. Okay, fun. I'm going to use 2 different colors. So we kind of have some flexibility here. So if I want my line to be parallel, which is what I'm going to do first, we'll do this one in red. I want the same slope. So this one appears to be going, I'm just picking 2 random points, down 1, 2, 3 over 1. Make sure I look closely. Sometimes I gotta zoom way in. Pictures are hard to tell. 2, 3, yep, okay. So that one's going down 3 over 1, down 3 over 1. So if I want my next line to also be parallel to that, I gotta do the same thing. You can put your line anywhere. You can put it to the left of this line, to the right of this line. But what I'm going to do is I'm going to pick a random point. Bam, right there. And I want to mimic that same slope. For them to never touch, they have to be doing the same thing. So this one's also going to be going down 3 over 1, down 3 over 1. And you can repeat that as many times as you want. Okay. And as you can see, the line should look parallel. So I'm going to label this one. This one's parallel. And my slope was, let's see, if it's down 3 over 1, it's negative 3. You don't really need to write the 1. Okay, let's do a purple line for our perpendicular one. Okay, so we want this one to be doing the opposite thing. So since our original slope went down 3 over 1, we want to go up up 1 over 3. Okay, so I'm going to write, here's what we're going to do. I'm going to write, I don't like that pen, but that's okay. Perpendicular. I want my slope to be positive 1/3. So I get to pick any point again. Literally anywhere. A point anywhere on this whole graph. Let's say right here. But I want my slope to be 1/3. Up 1 over 3. Up 1 over 3. Up 1 over 3. There you go. And that purple line should look like it's intersecting at 90 degrees. I'm going to put my 90 here. So that's how you construct parallel perpendicular lines. You use the slope of the line you're given, which we practiced counting slope, rise over run in previous videos. All right, so last but not least, let's talk a little bit about horizontal and vertical lines. Those are kind of our two special cases usually, so it's important that we understand them. This is review. Horizontal lines, which obviously look like this. Think of the treadmill. If I'm walking on a treadmill and my treadmill's flat, that means my incline is on 0. That's kind of like your slope. So horizontal lines have 0 slopes, or you could just say the slope is equal to 0. Now, vertical lines, think about my treadmill again. Can I walk up a treadmill that's straight up and down? No, that is way too steep. The steepness for that, we don't even have a number for it. It's undefined. So obviously you guys can put 2 and 2 together. Horizontal and vertical lines, if you made them intersect, they should intersect at 90 degrees. So number 1, what slope would be perpendicular to the line x equals 4? So if you remember on a coordinate plane, if my line is x equals 4, that means it's going to be a vertical line that crosses the x-axis at 4. So this x equals 4 is a vertical line. So what slope would be perpendicular to that? Okay, a vertical line is going to have a horizontal line perpendicular to it. So my slope perpendicular would be 0. The slope of my original line is undefined. This says perpendicular, so I'd put 0. So it's like this is my original. This is the slope that would be perpendicular to it. All right. Number 2, what slope would be perpendicular to y equals -7? This one says y equals, so this is a horizontal line. It's a horizontal line that crosses the y-axis at -7. So our original line looks like this, and it wants the slope perpendicular to that. So the perpendicular line would be a vertical line. So it's the opposite. The opposite of a 0 slope is an undefined slope. This one, our m would be undefined. There you go. That's all I have for this lesson. Reach out.